and I had comments, but obviously we, it's like we had no. Okay, we're going to get started.
Everything I knew about ISX, and I've never implemented it. So. Okay. I wanted to make sure I had the details right before I thought about it.
Can we should, everyone take their seat, please, or leave the room? No one's listening. Hey, Tony P. and Alvaro. You could take it outside or sit down, one of the two.
Could someone please close the doors?
Someone in the back, if you could close the doors.
Thank you.
Yeah, we could send them around again, I guess.
All right, let's get started. Good morning, I'm Tony Lee. This is a talk on creating better hierarchy in ISIS. Next slide.
You have the.
I think
It works,
yeah,
actually.
Yeah, PDF.
As long as you do PDF, it works.
Cool. All right. Okay. So one of the things that's happening is that network architectures are changing, and lots of people are starting to implement routers using lots of littler routers. We started off using multi-chassis routers a long time ago, and those multi-chassis routers are basically lots of little forwarding engines wrapped around a network fabric. What we're seeing is that people are moving towards a better topology where all those little boxes actually are independent systems, and the fabric is actually becoming the data center fabric. Now what that does do is that blows out the system level abstraction that we have with a multi-chassis router, leaving us with lots more routers that we have to manage. We'd like to restore some level of abstraction so that we don't have too many entities hanging around. And in particular, in the case of the IGPs, the way we create an abstraction is by an area. If we have a bunch of areas, level 1 areas for data centers, then maybe we need level 2 to handle the POP. We kind of want level 3 for the WAN. So almost certainly we want level 3. Levels 3 through 8 are available. The folks who designed ISIS were somewhat prescient, and they very nicely reserved more bits in the circuit ID for us and did not use them. Right now, there are only 3 levels, 3 values that are defined. Bit 1 is level 1, bit 2 is level 2. You can turn on both if you're a level 1 L1, L2, but there's 6 reserved bits just sitting there. I'm proposing that we turn those on and make those levels 3 through 8. Here they are. Ooh. One important note here, I am proposing that we make a restriction that these bits are only set contiguously. I don't know what it means for a router to be in level 1 and level 3 and not in level 2. And that makes my brain really hurt. If you could explain it to me when I'm sober, I would appreciate it. If that's a comment, please come to the mic. The other things that we need to do to make this happen, we need a new Hello PDU. Right now we have an L1 IIH, we have an L2 IIH. We could go down the path of creating L3 through L8 IIHs, but I don't think that's strictly necessary. I think if we just create a new one, because we don't want to have backwards interoperability issues, but we could create one new one that allows you to advertise level 3 through level 8 IIH at one time. I think that's possible. We need some new LSPs, new PDUs for level 3 through level 8 LSPs. We need new PDUs for CSNPs and PSNPs, and that's all. Mostly this draft is about a giant request to IANA for a whole lot of new code points.
Les Ginsberg, so I'm still wrapping my head around this a little bit, but, and there's a bunch of nits here. I mean, do we get a new MAC multicast address for the IIHs because we got an L1, all L1s, all L2s? If we do this, I'd love to see us use 7356 encodings. In other words, 7356 is allowed for new flooding scopes, for example.
Okay.
So it seems to me we could make this work. You get some issues. There's actually no such thing in 10589 as an L2 only router. So circuit type 2 is actually illegal.
Okay.
It's supposed to be, 1 or 3. I mean, we found use cases for 2, but strictly, so I don't know. These are all kind of nits. But to me, it's more about defining how this should be used. I think we have to think about the deployment cases harder, I guess, or I'd like to see more discussion about that.
Okay. Thank you.
I have to admit, I'm shocked. I don't realize there's no just L2 operation.
Yeah. So by definition, an L2 router is an L1 router in whatever area it's defined to have, whatever its area address is.
Right, yeah, but I mean, there's no L2 only circuit?
No. There are many implementations that have this IS type L2 only or something like that. That's a convenient CLI so that you don't have to go to every circuit and say this circuit is L2 only.
Right. Yeah. Okay.
Okay, but the circuit type can be L2 only.
Yeah. Sorry, I misstated that.
Yeah, okay.
Sorry.
Right. So it's in an area, but it's not in any L1 circuits or no L1 circuits. There's no L1
You can have that, and we obviously have many deployments where people just did everything's L2 and they didn't bother with L1 for various reasons. Yeah.
Tony P, Juniper. So I think I'm on the newest version of the draft, which is Slim. My only question would be, so we assume that the highest level that gets configured or deployed is still connected, right? So we don't get any partition level problems.
Yes.
Like L2 partitioned, okay. And we probably do not care to detect what is the higher level, whether it's partitioned or not. We just assume people don't do stupid stuff like partition area 0 and SPF.
I'm not proposing anybody do stupid stuff.
Okay. All right. That would merit a clarification in the draft, I think. Okay. That's your observation.
Let me amend that. I'm not intentionally suggesting people do stupid stuff.
AC Lindema Cisco Systems. Let me just make sure I understand it right. You are keeping all the same semantics of a L1, L2 router, except it would be LN-1, level N-1, level N. So that you'd always have 2 contiguous levels.
Yes. And possibly more contiguous levels, right? And you could conceivably have a router that's L1 through L8, right? One router.
With circuits, a circuit would be in how many levels?
The circuit can be in as many levels as it wants, but the levels must be contiguous.
Okay. I got to think about that.
Yeah, my brain hurts too.
So I brought this up, outside. I haven't thought this through either yet, but I keep wondering if there isn't something where we have to configure the area according to the, in other words, say we have 8 levels. Level 8 would then be ignoring the area, but all levels below would be some prefix. I don't know if that's needed or not, but I'm wondering.
For sanity's sake, yes, it would make sense for the NSAP to be hierarchical.
So Stuart Bryant. So Tony, I think when you started, you said that you wanted to use one to be a sort of confederation that became a router. And right, so there would be some sense in having 1 and n as a discontinuous pair. If you were building, say, a level 4 router, then its subcomponents would internally be in their own level 1. So I could see cases where you might want to, if you only wanted to build a high order router, then you may use the lowest order in order to construct it. There's a special case, I think, for discontinuous.
I think Les is going to respond.
Feel free. I'm just thinking in terms of the application that was cited.
So this is where it's an interesting discussion. Deployment cases.
Right.
I think we need to flesh that out so people at least have some clue about what's good ways to use this. And, we could debate. I'm not so keen on having, level N and level 1, but if we can figure out why that's useful.
So
Okay.
the use case was the use case to me seemed to be the original cited one, which was 1 becomes the internal components of the router, and it sits in a higher order level. So if you're using 1 in the classic sense that it's like we use it today, then it doesn't make sense. But the cited case was that we were building routers a different way, and I think there is a case then for 1 being special.
Okay, I'm not clear on that, but maybe if we talk about it some more, it'll make more sense.
Yeah. I haven't found a case that I wanted to use discontiguous levels yet, but I do want multiple levels just for creating more hierarchy and more scale. So, okay, area abstraction. So actually,
Go ahead. I'll save it for after this. Okay. No. AC Linda, I was as speaking as chair. I think this would, if we were to adopt these drafts, this would be some drafts before we go to standardization. We want implementations.
okay, area abstraction. So this is actually should have come first because this actually helps motivate why we need more levels. So if you haven't noticed, let's see, we already talked about that. The way ISIS does levels is not very pretty. If you have a level 1 area and you want to transit a level 1 area, you have to take those transit circuits and push them into level 2. And they show up in the level 2 link state database. And if your data center is going to almost all be used for transit, you effectively push everything into level 2. That's a scale problem. We really like to be able to build areas and have them really be an abstraction so that we don't push all of this data up into level 2 and cause level 2 to congest. So how can we fix this? What we'd really like to do is to have a different level 1 abstraction where a level 1 area just looks like a single level 2 node. We'd like the internal topology of the level 1 area not to be exposed whatsoever to level 2. We do need to have all of the external connectivity represented, right? So everything that the level 1 area touches, all the level 2 connectivity does need to be there. So level 2 SPF still works. So what I'm proposing is that we're going to represent level 1 area as a level 2 pseudonode, a single pseudonode. Inside the level 1 area, we'll use the area leader mechanism that we came up with dynamic flooding. We're going to just elect someone to pick that pseudonode ID, and he's going to go ahead and advertise that throughout his level 1 area. On the external links, everyone talking outside of the level 1 area, we're going to use that pseudo-node ID for our level 2 IIHs. I.e., we're going to lie big time. Okay? Everybody outside now looks and sees that this is just a giant pseudonode. We want all of our area border routers now to tunnel back to the area leader and use that as a L2 virtual circuit. And that's going to give us L2 flooding within the area. And now, after that happens, our area leader now has full ideas about all of the level 2 connectivity for this level 1 area.
So you're going to tunnel the traffic, you said?
No, not tunneling the traffic.
Then you're going to, then the level 1 is going to have the complete level 2 topology to access transit, not topology, but all the routes, right?
So what's going to happen is level 2 is going to exchange LSPs across the tunnels. Okay, and the level 2 area border routers are going to have to be able to compute transit across level 1 area and provide that transit, but not and be able to transit L1 and only routers. Okay, so what we're let me get ahead of things.
That implies that the level 1 only routers would have to have all the level 2 routes.
No, I'm going to suggest something even sicker, which is that we tunnel from area entry to area exit.
Oh, okay. That's what I asked initially, and you said no. Okay.
But we're not using the tunnel to the area leader. We're doing it a direct tunnel from entry to exit. Okay, and that can be SR or GRE. I don't care. Okay. Back to advertising the right information. Okay, so the area leader now has an L2 database that contains all of the L2 information from all of his area border routers. That gives us the identities of all of the adjacencies for the area, and he can cobble all of those up and list those as adjacent to the pseudonode. He uses that to generate an L2 LSP for the L1 area. That gets flooded into L2 as normal flooding. The other L2 area originated LSPs that all of the area border routers are generating, those need to get filtered. Those should not leave the area. And some of you are going, ew, yuck. Yes, that's gross. Okay. But what's happening outside of this area is that we're now seeing a single LSP. It lists all of the external adjacencies and nothing more. The entire L1 area is just completely hidden. Okay. We actually already talked about the forwarding problem. All of our area border routers are full-fledged L2. We've got connectivity, our flooding connectivity is to the area leader, but that's not where we want to forward. So we actually want to compute shortcuts from entry to exit. And SRR, GRE, I don't really care. Whatever folks feel like is useful for tunneling today. New mechanisms. We need a mechanism for advertising the pseudonode. So a simple TLV to advertise that through L1. And that's about it. Everything else is protocol machinery. Any questions?
I could have benefited by some pictures. This kind of hurts my head a little bit.
Well, fair.
Maybe
duly noted. Next draft.
I just had one comment from OSPF. My experience with virtual links has been that, and I realize this isn't exactly a different, you've solved the problems different ways, but I always thought if we ever did OSPF v4, I'd get rid of them because of the added complexity. So we'd have to really think we wanted this, and we couldn't just by, share, you couldn't just share links like we are doing today, having a circuit be in multiples to handle the use case of transit.
Well, again, the sharing the links causes a scale problem.
Yes.
So if you've got another idea of how to achieve the same ends without the scale, I'm all ears.
Yeah, I'm just questioning the use case of needing an arbitrary area for transit.
It's pretty clear that that's going to happen sooner or later as networks scale up. If we don't have some level of hierarchy, then we end up with flat networks, and that has scale problems of its own. So really, our only alternative for scaling networks is to build hierarchy.
Tony, I didn't read the draft. I'm sorry about that. I'm trying to understand this. So you want to be able to transit, Cengiz Alaaddinoğlu, Siena. You want to be able to transit the area, lower level area, and then how do you set the metrics for the pseudo-node to the rest of it, right? You want to be able to get in here and get out there. There's a different metric than get in here and get out somewhere else from the area. How do you set this up? And if you are not careful, if you are inside, in the middle of the area somewhere, and you want to bypass this area, and if you're not careful with setting these metrics, can you ever go back? Because you are doing hop by hop. Let's assume it's an MPLS is hop by hop forwarding. In the middle of the lower level area, can you ever head the other way? Because you're looking at the destination. You don't really know you want to exit at this router in the packet, in the data packet, right? I mean, maybe you might have explained these in the draft. I'm sorry, I didn't read it. Just for
I did not explain this in the draft. There are no metrics that are advertised outside of the area. This is abstraction.
But
And with
this pseudo-node-
abstraction comes the pain of having suboptimal routing, right? We know this.
Can you look back? Can you have loops?
You can't have loops because you're actually getting the shortcuts computed through the area. That's not a problem.
So
But
you
you
are
don't
going-
get metric information either.
So you must have an encapsulation inside the area for the data packet.
Correct. Because inside the area, there's some L1 routers, and you're
Yes.
going to have to transit them.
All right, thank you.
Jeff, sir, a few questions. MT and traffic engineering.
I don't see that there's a problem with MT. Traffic engineering, obviously, since you can't see inside the area, it's abstracted away from you. You can obviously do TE within the area. You can even do TE for the transit traffic at the area entry, but external traffic coming in cannot control its path through the area. Again, this is an abstraction.
Any ideas to decouple it? So at least remember how we did RCPT on the boundary, so border node would know what's inside in both places.
Correct. That border router can manage a path within the area, but you can't do it from the head end.
Would probably require some extensions to signal particular capabilities and how.
There's nothing for CSNP to compute because he can't see the data.
But someone has to do it.
Well, again, the area entry is the best place.
Chris Martin, Arista, I just wanted to maybe help clarify, if you think about what this area, and I think this goes to your point, AC, where you're asking about a use case. Imagine because it's all in vogue, a leaf spine router, like a multi-chassis router. It's mostly folded CLO or a CLO topology. So the leaves in this case, the hierarchy is somewhat inverted. Typically, the top of the hierarchy would be at the root, and then you would have, in a multi-area case, the root routers would typically be the ABRs. But in this case, the leaves are more likely to be the inter-area connection points. And so you need to, in terms of abstraction, you're going to be coming at it where what would typically be like the level 1 router itself. And therefore, you have to make the whole area level 2 aware. And so this abstraction kind of hides that. Going to the point about, traffic engineering within the area, imagine a complete graph that's got full bisectional bandwidth, or a bipartite graph for that matter with full bisectional bandwidth. You don't care about the topology, just like typically you don't care about, we don't talk about traffic engineering between line cards and routers. So the thinking would be, at least initially, that it's just a complete graph or a bipartite graph with full bisectional bandwidth. So to your point, Jeff, you can just hide that information. I don't know if that helps clarify the use case maybe, but.
Tony P again. So yeah, I see first layers of the onions being peeled. So we took it, of course, all the way in PNI. And if you do that stuff, choosing the ingress into the area is something you simply can't resolve. You may end up on a bad ingress. So the only way we could deal with stuff with the PNI, we were cranking back, which you cannot do here, of course, right? So whatever you try, even if you try to advertise some metrics, you summarize the stuff and you end up advertising this full mesh with some approximation, with sometimes dozens, right? It's inherent limitation of abstraction. Abstraction is controlled lying, and there's something you simply cannot change. Yeah.
Correct.
Chris Martin, Arista, let me just reiterate, we don't have to traffic engineer between line cards and routers, right? Does everybody agree with that? So I don't think we have to crank back.
So if links fail within the L1 area, you can compute a new route. That's going to happen. Any other questions? All right, thank you.
What you want to summarize? Okay. I was just going to say I'd encourage everybody to read these. These are definitely interesting proposals, and we really haven't. We've kind of, for the base mechanisms of the protocol, we've kind of haven't really extended them too much. We had OSPF3 extended LSAs. That was a big step. And then we had some experimental things like TTZ, but we really haven't had. So this is definitely interesting. So I advise everybody to read it, and let's have a discussion on both the mechanisms and the use cases. Okay, Yuma. Hey, go ahead. Come on up. I'd like you to say which. I know you have this standards track. I read this and I was saying, okay, what's standards track? You can tell me what you're standardizing and what you're just recommending out of this, or whether it should be just informational.
Okay, it's a great question, actually. It was a mistake. If you see the 00 version, it's informational, but actually when we're uploading 01, I had a issue with what you call the, what is that? ID uploading tool issue.
Oh.
ID uploading tool issue. Torles helped me to fix that one. It was breaking up that time. It's something messed up there. I'll fix that.
Okay, so it is informational.
It's informational.
Okay.
Yeah. Okay, so my name is Uma from Huawei. So I'm going to talk about the ISIS multi-topology deployment considerations here. Next slide.
Does it work? Sure. I found the present mode, so maybe it works.
Is this? Yeah, it is PowerPoint, right?
Yeah. If it doesn't work, then we'll just. Okay.
Okay, so we know this multi-topology for last 10 years maybe. So I implemented multi-topology in my earlier life. So, but what's happening new? What's new here is people are seeking to use IPv6 only. We have seen earlier V4, you have V4, and people want to introduce V6 into the network. Now people want to use IPv6 only topology there. So the use cases, like, people are looking at, I talked to multiple people who are in the mobile backhaul and L3 DC underlays. Next slide, please. So what's the issue and what's the goal of this document? Goal of this document is to lay out the nuances around the ISS IPv6. So there are multiple ways you can do this IPv6 introduction based on your requirements, because we have two ways to do this essentially. So, but there are caveats in each thing. So I'll just explain that. So if you are transitioning from IPv4 to v6, there's no question about it. You have to use ISS empty RFC 5120. But if you are using IPv6 only, then you have two options. That's the main point of this. But if you confuse on this, you have a lot of problems. So, but my goal of this document is to lay out these various options we have. And if any folks you are trying to do this and you have any problems and if you have any inputs, you can feel free to contact me. Next slide. So I'll just go back and just two options we have is we all know RFC 5308 The moment you say IPv6, ISIS, people think about RFC 5308. I see some of the drafts, for example, DC underlay drafts. When talking about IPv6, they mention this draft, but I'm not clear whether they want to serve both IPv4 or v6. This case is a single topology mode, so you compute one SPF and one decision process, and you end up with both v4 and v6. That is a key point here. And the second thing is RFC 5120. It is a multi-topology. It has TLV 22 and 235, 237. It is per topology decision process, and you come up with the routing table. So, but MTID2 is called IPv6 routing topology. So that's source of confusion, which I understand from a lot of people. So next slide, please. So, if you are seeking to use 5308, so you have to think about network congruency. If you are only IPv6, you're not going to touch v4. It's fine. You go ahead with 5308, no issues. But if you are transitioning, you have to be very careful. One simple example I showed here is you have a network with all links v4, v6, except one link, which is v4, between Rx to RT. You have adjacency formed. So packet will be, the shortest path tree will go to R2 using that link, but unfortunately there's no v6. You get traffic black hole there. Despite there is an alternate path, Rx, R1, Ry, R2, that's not going to be used because the shortest path is Rx to R2. So this is the black hole issue, and the ways to fix this is only two ways. One is either you enable v6 there or move to empty, because debugging this kind of problems is extremely difficult in the big networks. Next slide, please. So the main source of confusion here is it's a topology or address family. That's the main source of confusion. The terminology is used is very confusing. MTID2 is called reserve ISIS topology. Maybe it's an address family, I don't know. So, but say for example, when you want IPv6 only, it's better safe to use MTID2, multi-topology. Then people say, I don't want multi-topology, I want single topology, I want IPv6 only. But yes, you still have to use MTID2, multi-topology, because if you ever use IPv4, you get into trouble. That's the problem. Next slide, please.
You mean if you ever use IPv4 only?
No, if you start, yeah, correct. So I don't know if we can do anything protocol-wise. We can do anything to mitigate this confusion, but I thought to put this a document so that the conversation can be easier. So people suggested me to put in the v6 ops because a lot of v6 only stuff is happening there. There's issues there, how to deal with it. This is an operational issue. So I just seek your suggestions if you have any comments or suggestions. That's a question. Oh, you let me go first.
Les Ginsberg, this is a well-known limitation of the protocol. It goes all the way back to RFC 1195.
Correct.
There's nothing new here. If you look at MT, you'll recognize that there is no limitation on an arbitrary topology. You can support whatever set of address families you want. 5120 did reserve particular values for specific use cases.
So you said address family, but it's called topology there.
I'm saying a given topology can be used for as many address families as you want. What we did in 5120, or what Tony did rather, is he said these particular values are reserved for specific use cases. It places no restrictions. If I want to use MTID 10 and I want to run v4 and v6 with some constraints or what have you, it's perfectly legal to do so.
I'm saying 5308 can also be used for v6. That's one of my point of this document.
You're absolutely correct.
Sure.
Yeah. That's why I say this is well known.
Sure. Oh, well known to a lot of folks, but a lot of folks don't know it. I can guarantee you on that.
I'm willing to, from a deployment standpoint, people don't fully understand this always.
Correct.
I'm just saying this was clearly stated in 1195. There have been proposals in the past. Philip Christian wrote a draft many years ago to support tunneling between different address families. Never got a lot of support, but this has been talked about a lot.
Okay, thank you.
Michael Abrams. So there is a mechanism, I believe, that if I forget to configure IPv4 addresses, on a link and bring up ISIS, it won't use it for IPv4, right? Okay, if I have an ISIS adjacency, and I have no IPv4 or IPv6 addresses on the interface, it's not going to use the link, right? Right. So can we do the same, that if you have multi-topology and you have two topologies, you need both v4 and v6 addresses? Otherwise,
No.
Okay.
No, we don't want to limit it, definitely. We don't want to require IPv4. The goal is to be able to go only IPv6. I have a question for you. Do you think, I know a lot of people who have lived with ISIS all their lives, you've deployed it. Do you think this draft is useful?
you're talking to me.
I'm talking to you.
I've not read the draft, but I think what I've seen so far, this seems very useful, because I'm sure that people are going to run into this problem, and this is poorly understood. People have like, I know I do this and then it make it go, and this could probably help.
Is this what I was hearing from your presentation was that this was maybe useful cross area or cross, like, in other words, outside of routing to you said v6 ops and stuff, right? Is it that people don't understand there?
Correct.
Okay. Les has convinced everyone knows.
He always does. Just takes a while. Tony P. Juniper. Yeah, mea culpa. So I was dead bent against putting reserved topology values, right? And it was the sales pitch and operational issue, right? If everybody has to choose the same topology, it's harder than if we say in the draft, this is the use case. We should have probably called it the V6 transition topology or something, or maybe have put something in the draft which seemed utterly obvious to us, that the topology concept is completely orthogonal to address family concept.
It's done.
No, publish 5120, whatever it was, with addendum.
Okay.
Point. Right, rather than schlep another draft that people won't find because it's completely decoupled.
Okay.
Just reissue this bloody thing as a 20 bis and put this not.
Nice.
Okay. About the best I can say.
Thank you.
Yeah, thanks.
So to reiterate on Uma's points, this draft is not meant for implementers of ISS. It's meant for consumers. And we spent quite some time with Uma building ISS, another company. There's so much misunderstanding, so many errors. So it's really to explain people what it is, what they should do. And I believe there's a lot of misunderstanding outside of this room how to use it. This is the intention, it's pure informational. It is what it is.
So it would be kind of like writing a paper in a magazine saying, this is how you deploy v6 in your network. And I don't actually see there being a problem with that.
This is what we often do in routing working group, and it's a similar approach.
It's not like we're standard.
But these things get lost. People don't find the links. Reissue and addendum, especially because the multi-topology is now beer subdomain coupled as well, right? So in a sense, you have more use cases.
Right.
Put on addendum and put these three things.
But I'm sympathetic to this, because the point is, he's trying to say, if you're going to, hey, you want to deploy v6 network, if that's in the title, I mean, multi-topology, that, should I go look at the appendix of multi-topology? How did I get there?
Yeah, Chris, point taken. Okay.
Thanks. Yeah.
Last comment.
Yeah, so I'll just make I'm sympathetic to the deployment, okay, but people can get confused, and there may well be value in writing a deployment guide sort of thing. But this problem is very clearly discussed in RFC 1195, okay, from 1992, whenever it was published, okay. I would also make the comment that, well, if we had thought about multi-topology back in 1988, maybe the first version of ISS would have had it. We wouldn't have had two different TLV types. But of course, we didn't anticipate that.
So Michael Abramson again. I think for you have to write a different kind of document for operational people who don't know the bit and nanosecond of the protocol. So I think we should have this kind of documents. It's like, okay, here are the bombs. Don't step on them. Okay, don't do that and don't do that because it doesn't work. And you can't get that from just reading the protocol spec.
Who cares? So this one.
Yes, you can, but people don't get it because if you just read, you don't get the pitfalls from reading the protocol spec. You want operational, very clear things, 5 pages or something, don't do this, best common practice or whatever.
Okay,
Yes.
we're out of time. Thank you.
So very short comment. We've been doing YAM tutorials on routing year after year after year. We go out to RIPE, Nanoc, and people tell us, how do you use it? So it's good to have a reference point saying, look, this is what you read. It displayed what you do.
Okay, this draft is, it's not a draft, it's just an update of the preferred path routing that I presented last IETF. So this summary of what's been happening last few months, and I just want to, just give an update to the team. Next slide, please. It's totally messed up. Titles.
Yeah, it's not pretty.
Okay, so what is this? So this is a new path routing mechanism in IGP. It uses the shortest path routing. It uses same SPF, but the value it brings is label stack reduction. The first value it brings in is label stack reduction in SR. The extensions are discussed in ISA separate draft because draft is getting bloated up. It's 20 pages. Then we put 2 drafts separately because OSPF contains OSPF V2, V3. There's so many encodings. So we split it up 2 documents there. It covers the core protocol extensions, the PPR ID, that's a forwarding identifier, and the path description sub TLV, and the attributes, optional attributes. That's the key for this extension. And also, it also includes the SPF changes required, the small change required at the end of the SPF for installing the forwarding entry to get the pen, dip into the pen, get the next segment, next hop, and install the PPR ID. And it also allows you to get the path concept. This is free OAM, transparent OAM, because as and when you remove the segments from the SR, you don't have the notion of the path. So it's free. You don't have to put extra labels. You don't have to put MPLS special labels to give the path notion. Next slide, please. So why do we need this? Yes, so this I touched base last IETF, but again, I'll summarize here. The first point is it reduces the path overhead on the data plane. You can put everything on the data plane, everything on the packet, but there are some issues with that. So for example, you have the hardware capabilities. Let's take about the MPLS case. If you talk about multiple labels, you already have, without any SR path seeds, MPLS labels on the packet, you already end up in 4 or 5 labels. How it is that you have VPN label, inter-AS label, most cases 2 labels, and on top of it, if it's mostly tunnel traffic, to dip into the packet inside, you need to put entropy label 4 and the path label eventually. So 4 to 5 labels. And if you have Broadcom chips, I'm sorry for that, you cannot put more labels on that. But maybe in future, new chips may be available, it can do more. But if you put services, if you put everything, and if you put in ring topologies, every label you have to describe, it's good with 10 to 12 or 15. I don't know how many labels one needs it. So MSD fixes this in the sense like, it at least for the controller, it will help you to understand, okay, don't use this path because I have a small router here. It cannot read these many labels. So it can avoid that path computation. So it is a constraint on the PCE, but it cannot give the alternate path, which is giving the similar traffic characteristics we are seeking to start with. It also, once you reduce the packet overhead, you obviously get the line rate. There are line rate issues. Otherwise, some hardwares cannot do line rate if you put large overhead in the packet. And for SRv6 case, it avoids fragmentation. It's a serious problem. When you hit this fragmentation issue, it will be seriously, you'll be in trouble. And the last thing, for the lot of 5G use cases, MIOT and URLLC, packet sizes are small. It's 40 bytes, 30 to 50 bytes packets. You cannot put header tags of 200 bytes, 100 bytes for the packets. For that environment, it is sensitive. For some environments, it's not sensitive. yes, if it is environment is sensitive, then too much packet overhead is a problem. So it also simplifies the OAM. It extends the data planes. You can add more data planes, and also it unique fast route can be done with this. Next slide, please. So a lot of people ask for how it is backward compatible or how it works with SR. It's complementary. It's a complementary control plane work. It works great with SR. It's an optional feature if you want to use for SR MPLS and SRH. You can reduce the stack size, and you don't have to use it. And if you have to do network programmability, and if you want to do extension, a lot of stuff there, you can go ahead and do it. But if you are using only for the path information, if you want to compress that, you can use this optional feature. It works great, fully backward compatible. Next slide, please. So there was a question on the scalability. There will be millions of paths. You have 1,000 node network, 1,000 links. You have 4 million paths. So theoretically, yes, there'll be millions of flows, not millions of paths. There'll be few thousand paths, in some environment even lesser. So it's a simply scale is PPR path route is a scale number of routes into the IGP. So you don't have to scale. The answer is yes, you don't have to scale. Yes, there are theoretical possible, but you don't have to scale that much. So the only thing is we are looking for is how we can reduce the global sRGB usage. The sits are premium because global sits are very few. So that can be optimized. So with this, we could introduce the new draft, the graph draft. I'll talk about it next slide. So basically what we're doing is in this, instead of a linear path, we call this as a branch. So we introduce 2 bits. One is source and destination. So for example, PDE1 is the source, ingress PE. PD5 is the egress PE. So if you are crafting a path, PDE1, PDE2, you describe the path. But if you just add 2 bits, like for example, PDE1 is a source. In the figure, PDE3 is a source 2, and the green was the destinations. So 4 paths can be compressed into 1. For example, PDE1 from source to, for each source expanded to each destination. So every destination should contain a forwarding entry. So the forwarding entry can be established. So with simple bits, you can extend it to, you can compress it. And if you don't want too many scale, you don't have to use this, but it's a simple feature, it can use it. And also you can, the same concept can be extended to build the graph, and this will even further compresses it. Next slide, please. That the details are in the draft. So the use cases we are looking at is actually low latency use cases, low and deterministic latency use cases, a lot of use cases, verticals. These use cases and requirements are covered in the HC working group, NGP working group. This was sponsored by Vodafone, BT, and BSI folks. And this has a lot of use cases, why it is required and where it is applicable, why the stack size is a problem. Next slide, please. And there were questions on what is the relation with the 5G DMM working group work and this work. So I presented the first draft DMM transport aware mobility in IETF 102 in DMM working group. So what it lays out is in the 5G, how mobility can be achieved with the awareness of the transport network. In the 5G, a lot of small cells, new mobility scenarios are coming up, and with the new N9 interface. So when mobility sessions are taken, you need to account for the transport path characteristics too, if the path is available or not. So that is one piece. And also, there are other work going on in the DMM to remove GTP in the mobile core, how SRv6 and programmability can help there. That's a separate work, completely orthogonal. This proposal assumes a overlay, and it's an underlay mechanism, and it doesn't try to remove GTP or something like that. So in comparison to SRv6, it's a different work, and it can work with SRv6. And GTP replacement, there are a bunch of options there being discussed in DMM, including LISP, ILA, SRv6. There's so many proposals. For all these proposals, if you use PPR, it can reduce the stack size. That's it. So there's still ongoing work. It has just started a few months back. We're still improving the drafts, and we are fixing some of the problems we found. And if you have interest on this work, please contact me. And if you have questions, I'll be happy to help you answer.
So I don't know where to start. I think you listed problems that you're trying to solve are not the problems.
Sorry?
The problem that you listed,
Yeah.
line by line, are not the problems. So I think you're looking to retrofit your solution into something that doesn't exist. Okay, the problem that doesn't exist. You're looking for a problem to fit your solution, and I think it's a reverse engineering. Can you go back to your slide number 3, please?
So I don't, you've got a long piece of paper there. We're sort of out
Okay.
of time.
No, I'll keep it short. I'm not going to everywhere. So, I mean, let's say, for instance, the traffic accounting. There's a solution for traffic accounting without adding any additional label at all. Okay. And it's not a problem. Okay.
How is that?
That is, you read my draft.
I saw that. I saw that. I'm asking.
Okay.
So you're doing
I
ingress
can-
matrix. So the problem with that is you will hit into, if FRR happens, you will mess up with your accounting. Be careful with that. If you promise SLAs, you need to prove it.
That is another discussion, but it doesn't mess up. The accounting remains good. And I can prove you this. Okay. O&M, you're introducing additional states in the network or additional program in additional rewrites in the network. O&M is going to be more complex. So you think it's simplifying it, not simplifying it, it's adding more. You whenever you bring something, you keep saying simple, 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 but by the time you're done with it, is a whole blob.
I didn't say simple. It fixes this problem. It's simple or not. It depends on person who is seeing it, right? So for the network state, we discussed this part. It's a binding state. Binding state also adds a network state. It's a fib entry. If you let's remove all the fib entries, it's a thin air routing. Then you.
Yeah, I mean, let's say you talk about scaling of stack is solved by binding state.
We're out of
There in
time.
the ISR
We're taking
architecture.
time away from the next presenter. It's not fair.
Ketan Talaulikar,
The
Cisco.
next presenter, please.
So Anu, Uma, why don't you initiate a discussion of this on the LSR list?
Definitely.
Okay, hello everyone. I'm going to present this OSPF extension for the prefix originator. Actually, in Actually, in last IETF meeting, we presented another draft about the inter-area topology retrieval, and in that draft, the prefix source router ID is considered as a general useful thing. So this time we modify the draft to add more use cases about this ID, and here this is a new draft. Okay, we will go through the use cases for this new TLV. The first use cases are the we can use this mechanism to retrieve the entropy label capability or the MSD information of the source router, which is in another area, because when the OSPF LSAs are traversed across the multiple different areas, the source router information will be disappear. So when the ingress LSR need to know the information about the entropy label capability or the MSD information of a particular prefix, it needs this TLV, a new source router ID, TLV, to get this information before it can encapsulate the appropriate label stacks to the packet. Okay, there's also other possible use cases, which is we can also consider to use this mechanism to collect the inter-area topology from the SDN controller. This is because in some situations, the controller may only have the BGPRS sessions with only 1 or 2 routers in the backbone area. And in this case, it needs a mechanism to collect or retrieve the topology of the other areas in the IGP domain. So in this case, this TLV can also help, and this will have some limitations, and this has been described in the appendix. Okay, here are the TLV format, which is very straightforward. We need a new sub-TLV to carry the prefix source router ID. And for OSPF version 2, this TLV will be carried in the OSPF version 2 extended prefix opaque LSA. And for OSPF version 3, it will be carried in the E inter-area prefix RC. Very straightforward. Here's a procedure of the operation. Basically, when the ABR receive the router RC in one area, it will need to generate the corresponding summary RCs, and with this new sub-TLV added to the extended RCs, and then it will advertise this summary TLV to the other areas. Then on the receiver side, the routers in other areas will need to obtain this source router ID information for different use cases as described in the beginning of this presentation. Okay, I think this is a very straightforward extensions.
AC Lindenbaugh speaking. As we had a lot of offline discussions of this, and the changes were that we removed there were different encodings, and there were some non-backward compatible encodings using the existing LSAs. Those were removed, and we only kept the OSPF v2 extended LSA and OSPF v3 not extended. The OSPF v2 link attribute LSA. No. What was it?
Here we can see for OSPF version 2.
No, the prefix.
Yeah.
Prefix attribute LSA. That's what I meant to say. And for the OSPF v3, we used just the extended LSAs. We took the non-backward compatible ones out of there. And then we moved, I'm going to butcher his name, Ajun?
Ajun, yeah.
Yeah, I didn't butcher it. All right. Okay. Ajun had a use case that he wanted to use, and it didn't work for all cases. It only worked if you had all numbered links. And there was so we didn't want that to be normative, so we moved it to an appendix. Those were the major changes.
Yes.
Just answer. So self-works useful supported with regards to use cases. Usually, route capabilities are not meant to be propagated across areas. They're there, and that's why we do BGPLS work to get them up to the controller that builds full multi-area, multi-level graph. So specifically for that reason, we usually deploy pair of BGPLS speakers per area level, not per network. So I would really change the use case.
Yeah, that is, that's why we put this use case into the appendix.
Yeah.
Some of us would have preferred to see it removed after the long protracted discussion on it, but my compromise was appendix. So we might be discussing this one a little more on the list, if we can, because I think everybody agrees the TLVs are needed because they're in ISIS right now. The same thing, the inter-area propagation of the source router. And I'm not sure everything it's used for, but I think it's a good idea. And you have a BGPLS draft as well, right? Did the BGPLS draft get adopted?
Yeah, that is a different one.
No, but yeah, I know. But did it get adopted?
Yeah, I think so.
It did. Okay, yeah. So now we have it in ISIS. It's been adopted in BGP. So I think we're gonna look for adoption here as well. I might not need to be an offer, but.
Okay.
I ended up one based on all our offline discussions. Okay, I guess we're done. Thanks everybody. Sorry for all the problems with the Chromebook. I think there's a couple things we've learned that, well, the one thing, I think we figured out that the reason we couldn't find some of those presentations was those were the ones that were in PowerPoint, and those do not show up on the agenda page. You have to go to meeting materials. And also, if you don't convert the PowerPoint to PDF, it makes it very hard to step through it using the Chromebook.
Yeah, so I guess from now on, if you're writing a presentation, put it in PDF.
Yes.
All right, thanks everyone.
Thank you.
比那个发射邮件。
I'm watching it here. Oh, you were able to see it there? Okay, good. Nobody tried. I was actually remote in Brazil or whatever, and there was one working group where I'm like, yeah, I'm like Jabber messaging people. Actually, I was because of my distance. I can't see things. So